by your seat. So if it's something where you need to put it like in a desk in front of you or desk behind you, or clear off some things of your desk so that's not spilling all over, just be careful. Just be careful. He's looking out. He's looking out. All right, here we go. Section 3.2. Number 2, the answer should have been 10. What was that? What was that question? The base of the common log? Something like that. Number 8. You could have rewritten it, logarithm to exponential, 9 to the power of both sides. So 1 over 81 is 9 to the negative 2. Number 12, from exponential to logarithmic form, you could have taken log base 9 of both sides. So 3/2 is equal to log base 9 of 27. Number 16. Oh, that was hard. 1/2? Wait. 5 to what powers? Wait. 5 equals 25 to what power? Why is it 1/2? 1/2 as a power is actually a square root, right? 1/2 as a power is actually a square root. Kyle, what's up? Sadly, no. Because negative 2, remember, is a 1 over, so it'd be 1 over 25 squared, so 1 over 625. Yeah, that's rough. So remember the difference. 1/2 is the square root. Negative exponents just make fractions. Yeah, struggle, huh? So we want 25 square rooted to be 5, not 25 put in a denominator and squared. Number 28 has to do with the inverse property. The inverse property, 9 to the power of log base 9. They undo each other, 15. Haha. Number 38 was a matching, but there's their rationale as to why the answer is D. But that's the rationale as to why the answer is D. Oh, they didn't get the other one. Okay, moving on, right? Do we have some more evens? Let me give you guys just a second. There's 40 and 58 and 76, and I think that's the end of our evens. So let me give you 1 second to check those. Rachel, can I have you put these in the right period, and then just keep going with week 10, 11, 12. All right, questions on evens? Yeah, Tony. 58. Okay. I'm going to go peek at the book real fast so we can see the directions on 58, but is there anything else? Sorry, I think I saw a couple of you guys still writing. 58, I see a decimal answer, so that's why I'm grabbing open my calculator really quickly just to make sure we know how to use that. But the question on 58 said, or the directions I should say, use a calculator to evaluate the function at the indicated value of x. So remember, at the indicated value of x, they're just talking about f of the specific x. So we're just doing a plug and chug. So with that plug and chug, take 0.74, putting it into the function, what we put in there needs to go in there. So f of 0.74 as x is just 3 ln of 0.74. So if that makes sense, Tony, my guess is just something went a little funky when you put it in your calculator, which, yeah, that makes sense. That makes sense. Super easy to do. But otherwise, plugging and chugging should get you there. Anything else, evens or odds? Give me a thumbs up if you're like, nope, I'm good to move on. Okay. Mostly thumbs up. No more questions. Going once, going twice, and sold. All right, guys, notes open. Section 3.3. Quick reminder, Angelique, it's kind of specifically for you, but also for the rest of you guys. Remember, if you're absent and for some reason that delays homework being able to get turned in, There are YouTube videos online, of course, of our lectures. There are the PDFs. Wait a minute, where are the PDFs of notes? Let's say maybe YouTube isn't working or you don't have the data necessarily to be able to watch YouTube at the time, etc. tinyurl.com/doecmath. Good. Your guys' resources, honors pre-cal. What are the two most helpful resources here? I would say class folder number 1. Well, class folder and the YouTube videos. It's kind of all the same thing down here. And we'll go peek at the class folder to remember really quickly what's in there. But something else that's important on the website is also class calendar. Because remember, every time we start a new chapter, I go ahead and I post on the calendar everything up until the next test. When's the next test? Next Thursday. So a week and a little bit. So just trying to give you guys a heads up, but also remind you of how you could be giving yourselves a heads up. Because I'm not always able to take you here and remind you, et cetera, et cetera, et cetera. But it's all nice in the calendar. Sound good? Cool. So let me go ahead and remind you really quickly what's in your class folder. Class folder, we have PDFs of the notes. That's some way or a way that you guys could even go and download it to your iBooks if you want. And you could have the notes if you need to be copying them down at school, et cetera, or if data is rough. You get the notes that we take every day. I just keep one file for the entire chapter, and I keep adding to it every day what we've covered. Okay? So there's the PDF of notes. Another option for trying to stay on track and stay up to date without the YouTube videos. But then also, what else is in here? Remember, the homework sheet for the entire chapter. I try to post that at the very beginning. So if anything ever does disappear in Google Classroom, or you want to get ahead, et cetera, come in here and grab out the homework sheet. You don't need to wait until it gets posted in Google Classroom. Why does Google Classroom just kind of give you one assignment at a time and not really let you get ahead? Because if I were to put them all in, you'd have to go find the right one for the right due date, and it gets kind of complicated, and people end up putting pictures in the wrong one, and then it gets all confusing. Anyway, so I try to have it super nice and neat as far as this is what's next, get this one done, but here's where you can come and get ahead. Just a few of you guys had a couple extra days to get ahead, and you might have been able to move on if you had remembered about our website. All right, so all that to say, you do not need to fall behind in this class, but if it's something where you're absent, you get stuck, etc., you can post a comment in Google Classroom and say, hey, remember I was absent, that's why this is a day late, etc., etc. Okay, let's go ahead and section 3.3, more logarithms. This is where, to be honest, in some ways, I start to have fun. Maybe you will, maybe you won't, but this is where we start to actually get playing with puzzles a little bit better. Not that we're totally to the hardest puzzles of the chapter, but even like a Sudoku, how you start off easy and you work your way up, same thing here. Sections 3.1, 3.2, kind of laying the foundation, getting the ground rules. Now we have to kind of get into a little bit more strategy. Rules that you're not going to face all the time necessarily, that aren't the fundamental how to get started, but ooh, you know what, when you face this, it starts to get tricky, etc. This could be like with some of you guys in video games, how you actually start going on YouTube and watching people like how to pass certain levels. That's kind of where we are now. We're getting more specific. It's not the basic foundation. We're getting a little bit more advanced. Tony. Now we're talking about how to get through specific levels, how to face specific types of problems that are a little bit more advanced. Kyle. Oh, you know what? We're actually just going to fill it in because we already talked about it. Does anybody remember the change of base formula? Log base A of x. How do we change it? Good. Log base b of x over, it's a big old division, log base b of a. And remember, I'm saying, I think, the two most practical applications of this would be ln of x over ln of a. That's a different log base. ln is different than this log base a guy. Or common log of x over common log of a. I shut the door last period because the little middle schoolers were milling about. But let's open it because it's kind of warm and cozy. You guys got some donut holes in you. It might give you immediate energy, but then you might crash a little bit, especially if it's warm. Okay. So, however much space that needed, Kyle. There you go. Discoveries. Simplify the following. Huh? Discoveries. Simplify the following. Instead of making the page a little bit longer and a little bit more squished, let's go ahead and take a new page for this and say, how can we legally simplify that? What do some of you guys think? I'm just going to rewrite it. You only have to write it once. A log base A. Well, do we dislike the base, though? I think I like the base. What's true about the bases right now? They're all the same. Does anybody have an idea? It's perfect, though, because that's what most people's brains would do. If you understand the whole inverse thing between exponential and logarithmic. Because the whole inverse thing between exponential and logarithmic, didn't last homework, weren't you able to do stuff like, yay, and then be like, u plus. But why is this harder? Are we allowed to do that? Have we seen this? Have we faced this level yet? No. Okay, well, what do we do? We're making up some stuff and doing some illegal math right there. And that's okay. I get why you did that. Or if you thought that. Robbie, like, that's great that you thought that. Because you're like, hey, they undo. That's good, except they don't undo quite so nicely right here. We actually have to think about what's going on when you add in an exponent. Ooh. Ooh. Algebra skill review. What goes on? How do we get like x to the a plus b? Where does this come from when we add in the exponent? Yeah, why is it not plus? If it was plus, they're not like terms. Like an x squared to x cubed can't get put together. But an x to an a times an x to the b says, hey, you have a x's multiplied together, b x's multiplied together. You have a plus b x's multiplied together. So if it's x squared and x cubed, yay, it's x to the fifth. We have 5 x's all multiplied. So we're going to take this quick little algebra review. Property. And we're going to apply it to this and say, oh, so you had to come from a to the log base a of u times a to the log base a of v. Addition in the exponents comes from multiplication of the bases. So Robbie, you were so close. The a and the log base a's, since the log base a is in the power, they will undo each other, but it's not u plus v, it's u times v. It's not u plus v, it's u times v. And here's the really, really, really cool thing. You guys just discovered, if you can put it all together, the first property of logarithms. Because check what I can now say. I can say a to the log base a of u plus log base a of v is equal to u times v. The logarithms only. What would I have to do to both sides to get up to the logs? How do I undo this a to the power of? I wish it was a square root. A square root undoes the powers but doesn't undo the base. A log can undo a base. But what I do to one side, I have to do to the other side. So now I can end up with what's left over. That's all undone, log base a and a to the power of. What's left is his exponent. This is what we call an expanded logarithm. And this is what we call a condensed logarithm. A condensed says, oh, hey, I can express it all in one logarithm. U times v in a log is the exact same thing as the expanded form, log of a of u, log base a of u plus log base a of v. In some ways, this guy is simpler because what's inside is simpler. It's broken up. In some ways, this is simpler. What's inside is simpler. It's broken up. But in some ways, this is simpler because the logarithm is only in one spot. So sometimes having a log in one spot will be helpful. Sometimes having it spread out will be helpful. Hey, if you were like going up in battle, isn't it sometimes helpful to have all your guys spread around like for a guerrilla warfare sort of thing, right? You can come at them from lots of different directions, but sometimes you just need them all in one spot to have that power force to go, right? Similar here. Okay. You can make this much more specific than I can because me and video games are not friends. Maybe the Lego ones, like Lego Star Wars, that one's fun. That's about it. All right, so coming back. I think I better go to a single page because now we're having a lot of details. Let's take a second. We could do something similar with every single property and show you why. Ultimately, every single one of these basic 3 properties of logarithms and how to rewrite condensed as expanded or expanded as condensed, how to pull them apart, how to put them together, pull them apart 2 separate logs, how to put them together 1 single log. Ultimately, they all come back to how do exponents behave. So we saw just a second ago, an addition, if this wasn't a power, ends up being a multiplication. A division, if it's in a power, ends up being subtraction. I should say if a division problem with like bases could be subtraction or would be subtraction of the powers. And a problem with a power to a power ends up being a multiplication of the exponents. I know it's kind of complicated when you see it in this form. But in the page before, you can go back and be like, oh yeah, that's right. The addition and the power ended up being a multiplication, and then we put it all together to see where the whole property came from. Maybe it's a way of remembering. Maybe it's a way of remembering. That might help some of you, but for others, it's like, nah, I just need to memorize. Okay, cool. Do what you got to do, but these 3 are super, super important. Not just how to go from the condensed to the expanded, but also how to go from the expanded to the condensed. Remember, we're learning rules. Wait a minute, has anybody noticed that actually this is the same thing as that? Just what's different with this guy? Oh, okay, so it's just applying the super snazzy property to a specific really important logarithm and saying, hey, he's a log, it's true, yeah. Hey, he's a log, it's true, yeah. Hey, he's a log, it's true, yeah. Why? Because kids tend to forget that ln is a log. He's a log like any other log, just with a very special base that is very important when applied to nature. Or I should say very useful, very applicable when it comes to nature. Very commonly found and used. So this one's the general logarithm property. This one's like, hey, remember ln, he's a log. So it works for him too. Now, as you guys get the rest of those properties, what I need you to think every time you come to problems is, what form is it in right now? What form is it in right now? So what direction do they want you to go? Robbie, what are you thinking? Yeah. That's what you're supposed to do. Why did Robbie just say, oh, hey, I think they mean expand? Why did he say that? It looks condensed, exactly. So maybe it's helpful for some of you guys to make little columns and be like, oh, hey, this side is the condensed side. It's in condensed form. This side is the expanded side. Same thing with the natural logs. The left is the condensed, the right is the expanded. So if you have condensed, the directions are almost always to expand. If you have expanded, the directions are almost always to condense. Why? Because they just want to make you work hard and give you busy work? No, because we're going to have puzzles soon where it needs to be, meaning the logarithms need to be condensed in order to solve, or need to be expanded in order to simplify. So we have to be able to go back and forth. They're going to make us practice this skill. But how do we do that with A? B is easier. B is easier. B is easier. What do you guys think we're supposed to do with B? Yeah, we could do the quotient property. Actually, you know, does anybody notice that the fraction isn't even reduced? Huh. I mean, I guess we could reduce it. Is that easier? Okay. What happens if we do reduce it? It's kind of weird. I wonder why they didn't. Let's see if there's a purpose to it. 3 goes into 9 3 times, right? And into 300 100 times? We'll see if that helps. I don't know. I reduced it first. But now, you guys were using the quotient property, right? So we can make it common log of 3. Do you guys agree with common log of 3 minus common log of 100? Why on earth, besides just making us practice a skill, why could that be a helpful thing? 100, log base 10 of 100. Hold on, 100 is 10. So what can I do if I have the bases matching? Common log is a base of 10, and I have a base of 10. What can I actually do with that? Yeah, I can cancel that out and just make this a big ol' 2, right? Now, base 3 minus 2. I don't think that's a good form. I'm going to put negative 2 plus log base 3. Does anybody know why I'm doing that? Why do I not like it written like that? Yeah, do you subtract them? Do you keep them separate? The log is of the 3. It starts to get super confusing if you're writing numbers after a logarithm, because it's like, is it inside? Is it not inside? And some of you would make a mistake. So if there are any whole numbers that do end up resulting, aka non-logarithmic numbers, put them in front, so that you don't get confused. So did it help expanding and pulling out, I should say, expanding the condensed form? Did it make it a little bit nicer? Some of you say yes, some of you say no, but remember, that's not the point. The point isn't right now to know exactly where you're going. The point is just to develop the skill. Okay. So, why is this under the properties? Power property? What do you mean? I could make it 2 cubed, right? I could make it 2 cubed, but does 2 match 4? Kyle said the power property, so I was thinking that 8 is a power. Isn't it the cube of 2? 2 times 2 times 2? But 4 and 2 don't match. What else can we do with 8 besides make it 2 cubed? Oh, 2 times 4. Hey, the 4s would match, right? So what if we were to make this log base 4 of 2 times 4? And then, can't we use the product property? Who sees something that can simplify? Yeah, log base 4 of 4. Remember, it gets undone, but it becomes the power. What's the power of 4 if there's no power written? Understood 1. So what's this whole guy going to simplify to be? 1. Why am I going to write a half right here and say, oh, yay, it's 3 halves. Dun, 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 dun. Because 2 is the square root of 4. I've been a little too fast for some of you guys. Let me go ahead and show what I was thinking. I was thinking there's the plus 1. I could rewrite 2 to be 4 to the power of 1/2, or the square root of 4. Isn't 2 the square root of 4? And as soon as I figure that out, then I can say, oh, there's my 1/2. 1/2 plus 1 is 1.5. Or 1/2 plus 2 over 2 is 3 over 2. Okay. I know it gets a little tricky at times, and I know that I'm doing extra things like, oh, hey, by the way, that's 2. Oh, hey, by the way, that's a half. But are you at least seeing the skill of, if I have it condensed, I can expand and then try to do something? If I have it condensed, I can expand and try to do something. So expanding. Expanding. The idea is taking a condensed logarithm and using whatever properties you can in order to simplify, but I know in your head you're like, it doesn't look simpler. Okay, fine. But you're developing the skill that might come in handy, will come in handy, when we face some of these harder things to come. So right now you're just getting down the idea of, can I take something condensed and pull it apart? Can I take something all brought together under one logarithm, and can I separate it out? If you guys want to think of, if you're a history buff, this helps a little bit. You can think of something like the Allied and the Axis powers. Separate identities coming together under one common cause, like one logarithm. But it's not necessarily healthy. If that relationship continued forever, it's good for the separate identities to be pulled apart sometimes, not all together. Okay, England's political climate right now, maybe that helps. Not that ours is much better, but condensed, all coming together under one logarithm, expanded, being split apart legally under multiple. Maybe another way of thinking about it, if you're more of a finance person, bank accounts. You could bring all of your assets in one bank account. But we've seen banks fail in the last few years. The stock market crash, even with the Great Depression. It's not always good to put all your eggs in one basket, as the saying goes. So sometimes bringing it all under in one is good, but sometimes pulling it apart and having it spread out. Anyway, let's practice the skill. Expand. So, in letter A, let's zoom in on that guy, if I can zoom in. A little bit. What's something I can legally do to that guy? Each? What's each? 5? What else? What else? Yeah. Now, some of you would have put the 5 with the x cubed. That's good and all, but we can expand it even more. So we can do a log base for, what property am I using right now if I do 5 plus? Product property, good. Log base 4 of x cubed plus log base 4 of y. I'm done. Nope, it won't match the back because there's one more thing you can do. You're trying to simplify this argument as much as possible. I can't simplify that anymore. There's a 1, but I can simplify him. What property lets me deal with an x cubed in a logarithm? Yep, I can bring the 3 down. In some ways, the goal of this is to get the argument inside the logarithm as simple as possible. To get the argument in the logarithm as simple as possible. All right, there's nothing else we can do. You can look at it. There's a 4 and a 5. Nah. 4 and an x, a 4 and a y. Nope, nope, nope. All right, we're done. How about this guy? Can't we split those guys up? What would the first one be in my quotient property? Square root of. When you have, check out your properties. Quotient property. If you have ln of a top over a bottom, you can expand it to be ln of the top minus ln of the bottom, right? We're done. Nope. Because the square root is what kind of power? Square root. It's a 1 over 2. It's a 1 over 2. So can't I make this ln of 3x minus 5 to the 1/2? Just because a few of you needed to see that. Since the square root is a 1/2, I can make this side even easier. No parentheses, because the 1/2 or the square root only goes with the numerator, only goes with the first logarithm, doesn't go with the second. So I'm not factoring anything out. ln is a base of e. E and 3x minus 5, there's no matching there. E and 7, no matching there. All right, so dun, 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 dun. What else? Ooh, condensing. So expanding, we were taking a single logarithm and pulling it apart, spreading it out legally. Condensing says, let's go the other way. Can we bring them together? Under or into a single logarithm, under a single flag, under a single logarithm, in the same account, in the same logarithm. But guys, this is only legal if the bases match. Otherwise, there's no bringing it together. If the bases don't match, that alliance is not going to work. But here's something else tricky. I'm going to put a little hint in here. I'll put a little hint in here. Hints are good, especially because usually they come from the place of, ooh, it gets tricky and here's what to do when you face, right? So hint. Apply the power property first. If it applies, if possible, if it's in there anywhere, apply the power property first. If you don't, you're going to go illegal and it's going to be a mess. Does anybody see a power property in letter A? I do too. Where's their power? Right there. And where's he going to go? So I can have log base x minus log of x plus 1 to the power of. As soon as the power property has been applied, there are no other powers, there are no other coefficients besides 1. Then bring it together. Subtraction, isn't that division, guys? Dun, 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 dun. It's condensed. How about letter B? Is there a power property in here? Oh, there's 2. I see 1 here, and I see, who gets a power of 4? Because the addition would say multiply the 4. So multiplying the 4, wouldn't that mean both of them get the powers of 4? If your mind can legally make that jump, we can. The 4 would be times the ln of z, so ln of z to the 4th. The 4 would also be times ln of z plus 5, so ln of z plus 5 to the 4th, minus ln of z minus 5 squared. Wait a minute, I have an addition and a subtraction. The addition first? The addition? Yeah, like let's go left to right. So the addition, what would I do to those two? These two arguments, addition means multiply, right? So z to the 4th times z plus. And what's subtraction mean? See? I have my multiplication and I have my division all in one. It's kind of like that whole joint variation thing we talked about way back when. Or combined variation. We technically have another minute. This homework isn't due until when? Wednesday. Friday. Today's Wednesday. I know. It's not Monday. I know, it's weird. This homework isn't due until Friday, but let's see how many notes we have left to take. Okay. So could you theoretically finish it tonight? Yeah. We're going to have a bell work in the back of our spiral first thing tomorrow. Guys, didn't you get tests back last week? You didn't? Bummer, man. I'll make you a deal. Work on this homework tonight. Maybe not finish it entirely, but work on it tonight. You'll get your tests back tomorrow. We'll have them do corrections due after the weekend. Sound good? Yep. Okay, go team. Gavin. Yeah, I will. All right, get out of here, cool kids. I'll let you out 5 seconds early. Spoiled, rotten. Happy Wednesday. You're welcome, guys. Throw out your cups and your napkins on the way out. If you want your tests early because you want